Hey everyone, my name is Henry. I'm one of the co-founders of Snorkel AI, where we're building Snorkel Flow, our data-centric AI development platform. I've been working in the Python data AI ML world for a while now, and then with Arrow in various capacities between Stanford, which is where we started Snorkel as an open source research project, Facebook, where I was the tech lead for the representation learning team and the applied AI org, and now at Snorkel. I also just love getting way too technical about this kind of stuff with a great community. So super excited to be part of the data thread this year. The folks at Voltron are doing really cool stuff with the Arrow ecosystem and beyond. They're good friends of ours here at Snorkel. So again, just excited to talk to you today about how Arrow is helping us power data-centric AI development in Snorkel Flow. Some of the folks here might be familiar with the idea of data-centric AI. Others probably not. Might sound a little funny at first, right? Isn't just about every AI system built using data. It's an idea that we've been working on for years now, right? First at Stanford and now at the company at Snorkel. I promise we'll get to that in a little bit. But why don't we go ahead and get started by looking at the three big ingredients that go into building an AI system. So first you have the models, the software implementation of the kind of standard machine learning or the latest and greatest deep learning models that are actually powering intelligent systems. Second, you have the hardware, the accelerated compute infrastructure that you need to train modern machine learning models efficiently. And then last, you have the training data. So for supervised learning, the vast majority of enterprise use cases that we see out there, you need to collect tens, maybe hundreds of thousands, or even millions of data points, all labeled with the correct answer that you want your model to learn to replicate. So just give an example, like I'm trying to build a spam email detector, right? Taking an email, say whether it's spam or not. That means that I first have to collect thousands and thousands, again, maybe even millions of emails, each one labeled with whether it's spam or not, right? To use to then train my machine learning model. As many folks know, there's been incredible commoditization of models and hardware over the last 5 to 10 years. So we have those little check marks there, right? Modeling frameworks like TensorFlow and PyTorch, next-gen language models like BERT, GPT-3 even more recently, and then access to GPUs and TPUs through the cloud, I should say. It's been an unbelievable boon for ML practitioners like myself, right? But that last ingredient, the labeled training data, has seen almost no innovation in the last decade. The practitioners that we work with out in the field, these are top data science teams at banks, at telcos, at biotech companies, at insurance companies, even tech companies, right? They still find themselves stuck on the data. No way to efficiently create the large training data sets that they need to power modern ML models. And it goes deeper than just labels, too. The vast majority of the enterprise use cases for AI, right? They're looking to take advantage of unstructured, unlabeled data, right? 85% by some estimates of the data that enterprises are looking to operationalize for AI initiatives are unstructured and unlabeled. Think PDF documents, web pages, conversational transcripts, maybe even just raw text data, right? This forms what we like to think of as the iceberg under the surface, right? An incredible amount of potential if that type of data can be operationalized for AI usage, but the tools just aren't there for most enterprises today. So data science teams, find themselves relying on extremely manual approaches to get data ready for AI usage. And the biggest bottleneck is manual data labeling, right? So that looks like typically either asking internal subject matter experts, maybe if you're in the insurance industry, asking underwriters to label data for you, or if you're in medical imaging, maybe asking radiologists to label data for you, right? But in any case, they're hand labeling every single one of the thousands or millions of data points themselves, which can take weeks or months of time. It's also a huge opportunity cost, right? These are experts. They have knowledge of the field. They can be using that for kind of more productive work than just hand labeling individual examples. And then there are crowd working services out there, but those end up being a non-starter for many of the enterprises that we work with. Again, because of privacy constraints, like a bank, they just can't send their data externally. It's too sensitive, or needing domain expertise to label the highly proprietary data sets that people are looking to take advantage of, right? The folks on these crowd working services doing the work may just not have that domain expertise, and so can't label data with high quality. Okay, so even if you do manage to scrap together a manually labeled data set, the job isn't done yet, right? Your model might not be performing well, your data distribution might shift, the modeling objectives might change, right? We see this all the time. The business first told us that we were trying to categorize documents into one of 4 classes, so we got our data set labeled for that. They come back and tell us, oh, now it's one of 8 classes, right? changing needs with the business, we need our development practices to change with that as well, right? All of these necessitate extremely expensive relabeling, especially if you're doing it manually. And you keep incurring this cost over and over again, all while development is fully blocked until you can get an appropriate data set built. Okay, so hopefully I've convinced you that this is a real problem, right? For many of you, no convincing needed, right? These are challenges that we face time and time again. Every single data science team that we work with, we see them coming up against issues just like these. And that's what we've been working on for years now, right? First at Stanford and now at the company, the idea of breaking down this bottleneck by automating the data labeling process and generally accelerating AI development overall. There have now been 65 papers published on Snorkel Tech. We've partnered with core teams at Google, at Intel, many others from even the very earliest days of the research project. So it's an absolutely amazing thing to get to build the tech around some of these real world cases and kind of bring it forward as we're building the company as well. We've pioneered this idea of shifting from model-centric AI, where you're really just focused on tweaking and tuning your models while keeping the data fixed, to data-centric AI, right? And this is the idea of giving people the interfaces and the workflows they need to focus on building high-quality training data, right? The data that is going into these systems, giving people the tools and interfaces to engineer that directly. We're bringing this all to life with Snorkel Flow. That's our enterprise AI platform. It's built to help data science teams create really high-quality training data sets and models much more quickly than they've been able to before. And we do that through this idea of programmatic labeling, a technique that we pioneered that provides, in many of the real world use cases that we see, like 10 to 100x speedups over manual labeling. The idea is that rather than hand labeling individual data points, domain experts will instead describe the information that they're looking for when labeling to Snorkel Flow directly. So to give an example, maybe that's a set of keywords or a pattern like wire transfer for that spam email use case that I mentioned, right? You're looking for that content in the email. If it is, then label it as spam, right? Maybe you're cross-referencing a database. Maybe you're looking at how many spelling errors there are in the email. Lots of different possibilities. And we want to make it as easy as possible for people to bring to bear all the organizational knowledge that they have. Snorkel Flow will then apply and denoise those what we call labeling functions across your entire data set. So again, maybe thousands or millions of data points. And that lets you label training sets at machine speed, right? In minutes or hours instead of weeks or months that it typically takes with manual labeling, but still while leveraging the really rich domain expertise that you have within your organization. In Snorkel Flow, we give you like an IDE-like experience. We call that Studio. It's going to be the star of the show when we get a little bit more technical here in a bit. But the idea is to help you build and label training data sets quickly. We give you access to the model zoo that we have built in Snorkel Flow, or can let you integrate with your favorite modeling library or service externally, and then automatically update your model using the latest information that you've provided for labeling, really helping guide the development experience with using a model in the loop, right? And then we also generate analyses so that you can really rapidly iterate on your training data, on your model, again, all guided by the feedback that Snorkel Flow is giving you in as close to real time as possible. This is a totally new way to build training data sets, to build models. And it's really completely unlike the very manual, slow, ad hoc processes that most enterprise data science teams are used to. One way that I like to think about it, right, as an engineer myself, is that what we've built makes creating machine learning models much more like writing code than, again, the kind of very ad hoc processes that are typically used today when the process centers around manual labeling, right? And again, this lets practitioners really rapidly iterate on their training data and models without having to wait weeks or months for manual labeling. Okay, so there's a lot going on here, right? It's clearly not particularly easy to build. We have an unbelievable team of snorkelers and a really healthy culture of what I like to call practical innovation, right? So this is trying new things, evaluating state-of-the-art tech, but always in the name of solving real problems and always choosing simplicity over fanciness. So let me tell you about how we scaled our studio service after we realized our first cut wasn't doing everything we needed it to, and kind of get into some of the technical design principles there. Of course, I didn't really do any of the real work here, right? I'm really just the slide maker in all of this. Will, David, and Monis did pretty much everything here, so all the credit goes to them. Okay, cool. So let's take a look at the requirements for Studio, right? What is going to make this a truly awesome development experience? So first, it has to be interactive, right? You need feedback fast on the labeling functions you're creating, the models you're building, everything else that goes into the development process here. Second is that it has to be scalable, right? We need to be able to build training sets large enough to power modern ML models. And that can, again, in some cases mean very large data sets. And it has to be flexible, right? This is a really important one. So let's take a little bit of a closer look here. So Snorkel Flow, as I mentioned before, should be able to leverage any piece of organizational knowledge that you have to bear, whether it's a simple pattern like we saw before, a lookup in an ontology, right? Maybe some old business logic, or potentially even another machine learning model, right? And so we can start to see the complexity starting to build a little bit here, right? Here, as an example, we might be comparing representations built or generated by a language model like BERT, right? So can get definitely more expensive, more complex as people start to express more patterns here. We also need Snorkel Flow to power development workflows for, again, that iceberg under the surface of unstructured but extremely valuable data sources. Again, things like PDFs or chatbot conversations. So it may not just be raw text documents or rows and columns of a spreadsheet, but these much richer, much more complex data formats as well. Okay, so this requirement makes it tricky to just grab a SQL engine or search engine off the shelf, right? And that's why we started to kind of build our own stack to help power this Studio experience. Let's take a quick look at what the first version of Studio looked like, at least from kind of a simplified stack view, right? So we have our warehouse layer, some combination of a relational DB, some organized Parquet files, pretty typical. When we work with data in Studio, it's usually after applying some fixed transformations to data in that warehouse layer, right? So what we typically do is apply those and then cache the result on disk again as Parquet files. This made sense since we were already using Parquet in the storage layer below. For data sets that we are commonly using, we'll also pull those into memory as data frames. And we have that in-memory data frame cache layer at the top left. This is something like an LRU cache. I'll get into more of this in a sec. And then we have our compute layer, right? And that can work either over the disk or the in-memory cache. That's where we perform operations for exploration, like filtering, sorting, aggregating, of course, things like programmatic labeling, really at the core of the workflow that we're building for people. And then there's some mix of Dask, pandas, and some Snorkel stuff in that layer. Okay, so let's grade this thing, right? So for use cases where you're working over raw text data, think maybe tweets or emails, and using relatively simple labeling functions like regular expression matches, and then also have like a single data scientist working on a use case, right? All of this works out. We get those three properties: interactivity, scalability, flexibility, at least within the constraints that we mentioned above, right? All good. But as you start to get more complex, the situation changes, right? And this is exactly what we saw as teams that were using Snorkel Flow were wanting to apply it to more and more use cases, kind of ladder up in terms of the complexity of what they were trying to do. Shoot, it looks like my GIFs aren't working, but show must go on. I think you get the picture, right? So you start working over, say, 100-page PDF documents instead of tweets, right? And all of a sudden the rows of the data frame go from a few kilobytes to multiple megabytes, and you start to have problems, right? That in-memory cache starts to become a choke point. You might run out of memory. You might thrash hard because you can only fit one or two data sets in there. Things aren't looking so good, right? If you're trying to then run expensive labeling functions over those more complex data types, again, think like a deep learning model, you might need your compute layer to deal with memory more efficiently, right? You don't want each worker to load up its own copy of the model into memory. And you need to horizontally scale, right? These operations are more complex. We want to run them in massive parallel as much as possible, right? You need all of this stuff to efficiently label large data sets. And then if a whole team starts using it as once, right, this just adds more pressure to those kind of existing choke points that we saw before around memory and compute. And we're pretty unhappy overall, right? So things aren't looking too good here. Things start exploding all over the place, and we don't get those three properties that we really want, right? In reality, what this would end up looking like is just a slower experience than you'd want, or not being able to have that interactive feel over as much data as you'd like. Okay, so zooming back in here, right, a pretty obvious suspect is that in-memory cache, right? This is always going to be a memory bottleneck, right? Especially with large rows, almost by definition. And it makes things tricky, definitely not impossible, but it does make things tricky to horizontally scale as well. So it causes issues for that data frame compute layer too. Okay, so backing up, you might ask why we even have it, right? Well, it's an even simpler architecture like this could just operate directly over the Parquet disk cache. But of course, Parquet is not really built for that kind of thing, for powering an interactive experience like this. It's more of an archival format, right? It's super efficient on disk, but it's expensive to read. It's also a columnar store, so we can't do things like filtering rows for exploration really efficiently. And just to punctuate this, not that we really even need to, but just to kind of really ground it, right? We get some sad behavior if we remove the disk cache altogether, right? It takes, let's say we're working with a 5 GB Parquet file. We want to load that up. And then sub-select like a gigabyte of data from, maybe the user's trying to filter things down, explore their data in different ways. Pretty common operation in Snorkel Flow, right? That operation takes 48 seconds using the Parquet disk cache, again, to filter, load up 5 gigs and then filter it down to 1. With the disk cache, or with the in-memory cache, I should say, it only takes 2 milliseconds, right? So 24,000x speed up, right? Who doesn't love that? It's pretty remarkable. So it seems like a choice that we'd make all day, as long as we have that Parquet-based disk cache in there. Okay, so let's recap, right? We have this interactive, scalable, flexible behavior with simple data types and simple operations, right? But that starts to break down when we have the multi-user and more complex workloads and data types. The in-memory data frame cache, mitigates the slow disk reads that we were seeing with Parquet, but one, it can cause memory issues, especially when you're working with complex data points that might be multiple megabytes each, and it makes it more difficult to horizontally scale the service as well, right? So the key question here is, can we mitigate those slow disk reads, but without needing that in-memory cache? That would be awesome, right? So in flies Arrow to the rescue, right? We had actually already looked at Arrow very early on when building Snorkel Flow. There are a couple things that weren't quite working for us back then. Since then, though, there have been a ton of improvements. Things like storing serialized objects, handling large rows, all that stuff that's actually really important for our use case. So it was awesome to see that level of development in Arrow in the last few years. When we took a look at Arrow again, we had already kind of rebuilt, or were experimenting with rebuilds of the compute layer, this time using Ray, working with our friends at Anyscale, and then Modin as the DataFrame layer that was working with our friends at Ponder. This had already solved a bunch of stuff for us, but we were still needing to get rid of that in-memory cache to really scale it efficiently. And that's where we started playing with Arrow again. Okay, so let's go take a look at that behavior that we saw before, this time as a chart. Again, it's pretty stark. Out of that not to scale because Google Slides doesn't support making bars that thin, but I think at least conveys the picture here, right? Okay, so what about Arrow? Just 1 second, right? So 1 second to go from the 5 GB serialized on disk, then bring it into memory, filter down to about a gigabyte of data. That's super interesting, right? It is still 500 times slower than in memory, but that difference becomes way less important when you look at what users are doing once they have their data, right? Take a labeling operation, might take 4 seconds over your full data set. So the interactivity gain of the in-memory cache really isn't worth the price you're paying in terms of system complexity when you're comparing it to that Arrow-based disk cache, right? This comparison rate isn't really even taking into account the speedups that you can get from horizontally scaling the workers now much more easily without having that in-memory cache. So I'm sure I could come up with some comparison that makes the Arrow-based version net faster overall, but even just staying single process to simplify things, the key point is there, right? Arrow lets us enable interactivity without having to have that in-memory cache. And again, this is enabled by taking advantage of really the core features of Arrow, right? Having super fast disk reads, ability to use memory mapping as well, and then a bunch of the user ops actually get faster in and of themselves, right? We get constant time random access that helps us load up individual rows when we're filtering down again for exploration, and then faster iteration over rows of the table since they're laid out much closer in memory. That helps with things like labeling an entire data set where you have to actually iterate over all the rows to apply whatever logic people are using to label their data. We're still rolling this change out to the full fleet, but our users are already seeing 5x speedups for really core labeling operations, 4x speedups on data exploration ops, and then 99% plus reduction in memory usage for most operations that people are performing. Right. That last point is huge for resource provisioning, and then reliability, maintainability overall. Right. So really important for both our customers and for us. It's rare that you get to see kind of this level of improvement just from kind of making a core change like this. So we're super excited about the way better experience that we can deliver to customers here. Okay, so wrapping things up, right? Using Aero to back our studio experience has been really the key to unlocking those three properties, right? The interactivity, scalability, flexibility that we're looking for in Studio, even over those much more complex user operations and data types. Again, working with that iceberg under the surface, unstructured data, PDFs, conversational data, and leveraging the latest and greatest and in terms of representation learning, and all the organizational knowledge that folks want to bear for actually kind of building out AI systems here, right? We have, from kind of doing this build, right? We have lots of other ideas for using Aero within Snorkel Flow, right? Including IPC, some parts of the data warehouse, and a whole bunch more. So super excited to keep working with the team at Voltron here as well. And that's about all I've got for you today. Thanks again for listening, and always feel free to reach out, learn a little bit more about what we're doing here at Snorkel AI. You can reach me, just an email is probably the easiest way. It's henry@snorkel.ai. Otherwise, have a great rest of the day checking out the other talks at the data thread, and I'll see you all later. Thanks.